Well, we're in section 7.4, and we're doing the pre-section videos for arc length. And the arc length is three basic formulas you guys need to know. It's the integral of the square root of 1 plus the derivative of whatever function they give you that you want to find the arc length of, squared dx. This is the function in terms of x. You take the derivative of that, square it, add 1, take the square root of it, and integrate that with respect to x. However, if your function is in terms of y, it is the integral from a to b of the square root of 1 plus the derivative of the y function squared dy. So you can clearly see a pattern on this. And another way of writing it would be, the square root of 1 plus y prime squared dx, or the integral from a to b of the square root of 1 plus x prime squared dy. Because x prime means you had x equals in terms of y. Or there's this third formula down here. Again, you'll see this formula a lot in Calculus 3 when you get the parametric equation stuff and do a lot of stuff with vectors. And the arc length for that guy is the integral from a to b of the square root of the derivative of x with respect to t squared plus derivative of y with respect to t squared dt. Because a parametric equation is an equation that you got x is equal to some function in terms of t, y equals some other function in terms of t, and t is defined between a and b. So this is what we call a parametric equation. So if they ever give you one of these guys, this is the formula you're going to use. So let's take a look at this first problem here, because these are problems that are very similar to your quiz problems. Make sure you guys understand. Okay? Which of the following integrals, well, basically I meant to say set up the integral. Set up the integral. A definite integral which defines the arc length of the curve of y equals sine of x between 0 and pi. Okay? So, if I wanted to do this, my function is in terms of x. That's what I want to focus on. So I know which formula to use. Arc length would be equal to the integral between a and b of the square root of 1 plus the derivative of my function squared dx. Now these guys you have to have memorized. It's just straight up, but they're easy formulas. So if y equals the sine of x, what's y prime? What's the derivative of sine of x? Cosine of x. And I'm going to plug that into my formula. So arc length would be equal to the integral between 0 and pi of the square root of 1 plus cosine of x, quantity squared, dx. And another way you could have written this, cosine of x quantity squared, is the same thing as 1 plus cosine squared x. And this is the way they like to type it in terms of answers on tests and things like that, so be prepared for that. But one other thing I want to mention about this one, because the question was just set up the integral here, and this is my answer, arc length equals this guy. But the real problem when it comes to this arc length stuff is straightforward. Sometimes these integrals can be quite nice, but that means they had to rig it up just right to make them quite nice. Most of the times these integrals are going to be quite nasty, which means we would end up using a calculator to integrate something like this, if not some table in the back of the book or something or other. Because these guys are quite nasty in terms of something like this. Okay? So some of those web work problems you've got to do at the end of the section, you're going to see those guys clean up very nicely, but those have been pre-worked out for you guys so they would clean up nicely. Most things don't. All right, try this one right here. Write up the integral, write the integral of the curve with x equals 2 over y between the points 1, 2, and 2, 1/2. Okay, if I'm supposed to find the length of the curve is arc length, but here I have x equals 2 over y. I've got x as a function of y, and 2 over y is the same thing as y to the negative 1. So pretty much my arc length formula for this guy would be the integral from c to d of the square root of 1 plus the derivative of my y function squared dy. Okay? But now I need to take the derivative of x, which will be y prime, f prime of y there, which will be, what's the derivative of 2y to the negative 1? Negative 2y to the negative 2. Straight up, take the derivative of it, and I would clean it up, so this would be negative 2 over y squared. But now I'm going to plug that into my function here, so my arc length would be equal to the integral of the square root of 1 plus negative 2 over y squared, quantity squared, dy. So there's almost my answer. I would want to clean this guy up, But before I clean it up, the last little bit is, what do the bounds have to be? What's my bounds? Well, this is dy. Pay attention to that. So we've been focusing on this dx, dy with all that stuff on the volume, rotation, everything. Pay attention to the variable. Since this is dy, we should use the y numbers. My y numbers are between, I got the points 1, 2 to 2, 1/2. My y numbers are 2 1/2. And the half, since that's the smaller number, will go on the bottom bound. And the 2 is my larger number, that'll go on the upper bound. Does that make sense? And the only other thing I would do to clean this up, if I can pick him up out of a lineup, would be the integral from 1/2 to 2 of the square root of 1 plus strict multiplication division. I get to distribute my powers. Negative 2 squared is actually 4, divided by y squared, power to a power multiply. That'll be y to the 4th power dy. And there would be my solution. Because both these problems are about setting up the integral. But you just have to identify what function, what formula you need to use, and being it's dy, pay attention, you want y numbers. When it was a dx, pay attention, you want x numbers. All right, so this one, try this one. Compute, this one they want a numerical answer for this one. Compute the arc length for the curve of y equals 4x to the 3/2. Well, y equals 4x to the 3/2. My function is in terms of x, which means my arc length formula is the integral from a to b of the square root of 1 plus the derivative of my function with respect to x squared dx. So y prime, my derivative would be, bring it down, that would be what, 6x to the 1/2. 3/2 times 4, 2 goes into 4 2 times, and 2 times 3 makes the 6. X, and subtract 1, don't forget you're taking derivatives, is subtract 1, you get 3/2 minus 1 is 1/2. I'm going to plug that into my function here. This becomes integral, and I got my bounds from 0 to 1 of the square root of 1 plus the derivative, which is 6x to the 1/2, quantity squared dx. This will be the integral from 0 to 1 when you clean it up, will be 1 plus 36x, because with strict multiplication division, I get to distribute powers. 6 squared is 36, x to the 1/2 squared is just x, dx. And I'm going to integrate this one by hand, but if I was working a test question, I would always double check my answers when using the calculator. But this one I can integrate by hand by letting u equal to 1 plus 36x. That makes du equal to 36 dx, which makes 1 over 36 du equal to dx. Plugging it in, this becomes the integral of the square root of u, and dx is 1 over 36 du. I'm going to just go ahead and integrate and then plug back in. So this will be 136 integral of u to the 1/2 du, which is 1 over 36. Add 1 u to the 3/2 over 3/2. No plus c because we've got bounds. So this is 1 over 36 times 2/3 u to the 3/2. Nice. Clean this up. 2 goes into 36 18 times, and 18 times 3 is 54. So I get 1 over 54 u, which is 1 plus 36 x to the 3/2. But I got bounds evaluated from 0 to 1. So fundamental theorem of calculus, I plug in top minus plug in bottom. 1 over 54 times 1 plus 36 times 1 to the 3/2 minus 1 over 54 times 1 plus 36 times 0 to the 3/2. 36 times 1 is 36 plus 1 is 37. So this is 1 over 54 times 37 to the 3/2 minus 36 times 0 is 0 plus 1 is 1 to the 3/2 power is 1 minus 54. Or for those people who love just decimals on the calculator, this is fine. So I'm going to take 37, raise it to the 3/2 power, divide that by 54, and then subtract 1 divided by 54. And I get 4.149300252. But of course, I could have made a careless error somewhere. We're all prone to doing something like that. So I would go back and double check my answer by using my integration button. I'm integrating from 0 to 1 of the square root of 1 plus 36x dx. And I feel much better about my answer. Of course, this is a computer calculating this with Riemann sum, so there may be a little bit of rounding off error, but yeah, pretty much I got the right answer. Does that make sense? Questions? Cool. Well, I hope this has been helpful, and I'll see you guys in the next video.